In this lesson, we'll be focusing on change of base in logarithm. Log n base b, by definition of logarithm, is equal to log n over log b. Now, if we want to change the base of this logarithm from base b to another base, we are going to assign, let's say we are going to change it to log c. We are going to assign c here and then c here. So log n base b is now equal to log n base c over log b base c. All right. You first of all write the number as the numerator, and then the base at the denominator. Okay. So now in this case, our new base, which is c, is not associated to any of these numbers, the n or b, is totally different from the numbers. Now, let's assume that we want to change this logarithm n base b to another base. Let's call it, this is log n over log b. So let's assume that we want to change it to a new base, which is n and then n. Now, in this case, our new base is associated with this number here. Okay, so there are cases where it will be associated, and then there are cases where it will be automatically different number. Okay, so let's look at this question so that you understand this very well. We have log base 0.2 of 125, and we have to solve this. So this is going to be equal to log, now 0.2 when converted to a fraction is equal to 1 over 5. Then we have 125 here. So at this point, we are going to employ change of base. So we have log 125 over log. Now 1 over 5 can be written as 5 raised to the power negative 1. Okay, because 1 over x is equal to x raised to the power negative 1. So that's just what we did there. So which base are we going to assign this logarithm? Are we going to use base 2, base 3, or base 4, base 5? Which base? So by careful observation, we can see that we're going to use base 5, all right, because you can get multiple 5s into 125. In fact, 5 can divide 125 without remainder, and then 5 can also divide 5 without a remainder. So that's why we adopted base 5 instead of base 2, base 3, or any other number. Okay, so this is now equal to log 125 base 5 over log 5 raised to the power negative 1 base 5. So our next step, you have log base 5 of, now 125 can be written as 5 raised to the power 3. Then this is over log base 5 of 5 raised to the power negative 1. Now this is equal to, we're going to take this 3 in front of this log. It's going to be 3 into log 5, then over, we are going to take this negative 1 in front of this log. So it's going to be negative 1 log 5 of base 5. So this and this is going to cancel, and then we'll be left with 3 over negative 1, which is equal to negative 3. So this is the answer to this question. Let's go ahead and solve other numerical examples. So as when we are given log 4 base root 2 plus log 16 base 1, 2, which is half, minus log 32 base 4. So I asked to evaluate this logarithm without using tables or calculators. So how are we going to solve it? So solution. So how are we going to solve it? Now, because this logarithm have different base, we're not going to do direct simplification by doing 4 times 16 over 32 as we normally do when they have the same base. So that is not going to work because they don't have the same base. So what we're going to do now is to employ the change of base. So for this one, 2 is common to 4 and 2, like 2 can divide 4 without a remainder. And then these 2 also can divide 16 multiple times without any other number getting involved. And then also 32, 2 can divide 32 multiple times without any other number getting involved. So we're going to employ change of base. So for this one, we have log 4 over log root 2. So which base are we going to employ here? Now 2 is the only number that can reduce 4 to its lowest term without a remainder. So we're going to employ 2 and then employ 2 here. The same thing is applicable to these 2. Then plus log 16 over log half. So the same thing is applicable here. 2 can reduce 16 without a remainder. And so we have minus log 32 over log 4. So the same base 2, because 2 can reduce 32 to its lowest term without remainder. Same thing is applicable to 4. Now this becomes log base 2. Now 4 can be written as or is equal to 2 square, then over log. Now root 2 is the same thing as 2 raised to the power half. So we have base 2, then plus log. Now 16 is equal to 2 raised to the power 4, then over log. Half, which is 1 over 2, can be written as 2 raised to the power negative 1. So let's not forget our bases. Then minus log 32 is 2 raised to the power 5, then base 2 over log 4 is 2 raised to the power 2 of base 2. So the next step here is to take this 2 in front of here, take this half in front of here, take this 4 in front of this logarithm, take this negative 1 in front of this logarithm, take this 5 in front of here, and then take this 2 in front of this logarithm. So this will be our next step. So let's take these 2 to the front of this logarithm so that we have 2 log 2 over half log 2 then plus we have 4 log 2 base 2 over we have negative 1 log 2 base 2, then minus we have 5 log 2 base 2 over we have 2 log 2 base 2, so that this log 2 base 2 will cancel log 2 base 2, log 2 base 2 will cancel log 2 base 2, and this will cancel, and then we now have 2 over half plus 4 over negative 1 minus 5 over 2. Now let's multiply both numerator and denominator here by 2 so that this and this will cancel. 2 times 2 is going to give us 4, then minus 4 divided by negative 1 is negative 4, then minus 5 over 2. So that this will cancel to 0 because 4 minus 4 is 0. And then we have minus 5 over 2 as our final answer to this question. So let's go ahead and solve one more question. Guys, if you like what I'm doing, please do well to subscribe to my YouTube channel and turn on the post notification bell so that each time I make a post, you'll be the first to get notified and then watch it. Thank you for doing so. So our final question states that given log 4 base 2, then plus log 2 base 4 minus log 5 base 25. We're asked to evaluate this logarithm. So I want you to pause this video and then try it by yourself and know how far you go with it. So solution. So let's employ change of base direct because this is base 2, base 4, and then base 25. So we can't go ahead and simplify like this without change of base. So like we did in the previous example, we have log 4 over log 2. So which base is suitable for this logarithm now? So the answer is base 2. Okay, so now plus log 2 over log 4. So which base is suitable for this logarithm? So the answer is still base 2, because 2 can divide 2 without remainder. 2 can divide 4 multiple times without remainder. And then this is minus, we have log 5 over log 25. So in this case, 5 is going to be the base we are going to employ here, because 5 can divide 5 multiple times without remainder. The same thing is applicable to 25 without remainder. So let's put 5 here. So this now becomes equal to log. Now 4 is equal to 2 raised to the power 2. Then let's not forget our base 2 over log 2 base 2, then plus, we have log 2 base 2 over log 4 is equal to 2 raised to the power 2, that is 2 square, then base 2 minus log 5 base 5 over log. Now 25 is 5 raised to the power 2, which is 5 square, then base 5. So we are going to take these two forward. Then we have 2 log 2 base 2 over log 2 base 2. Then plus, we have log 2 base 2 over, we take these 2 in front of this log, so now become log 2 base 2. Then minus log 5 base 5. We are going to take these 2 in front of this log, is going to be log 5 base 5. So as you can see, this and this will cancel, this and this will cancel, then this and this will cancel. So this will now be equal to 2 plus 1 over 2 minus 1 over 2. So 1 over 2 minus 1 over 2 is equal to 0. So our final answer is now equal to 2. Guys, please remember to subscribe to my YouTube channel, like, share, and comment. Then turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. Thank you for watching.